Ja, velkommen til dette Energiforum 21 live webinar. Mit navn er Erik Braun-Fransen. Jeg er genvalgt bestyrelsesmedlem i Energiforum. Dette webinar det handler om bygningernes rolle i den grønne omstilling. Driften af bygningerne bliver jo mere og mere kompleks i takt med større krav om intelligensparathed i bygningerne. Vi oplever mere komplekse styringer og ikke mindst energisystemets større rolle i bygningernes drift. På dette webinar får du indblik i, hvordan det bliver muligt at koble bygningen på nettet og få bedre styring af ikke blot traditionelle bygningsanlæg, men også bruge elbiler og batterier til endnu mere bæredygtig bygningsdrift. Dette webinar bliver afholdt af Anders og foregår på engelsk, så jeg går over til at tale engelsk nu. Welcome to this webinar, and remember to ask questions in the chat. You can write in Danish or English, but we prefer English, and then we'll ask the questions to Anders Norén at the end of his speak. So welcome to Anders, and we look forward to hear your interesting topics.
Thank you very much. Let me share my screen with you. So thank you for that introduction. As we are moving towards a greener future, I will in this session talk about the role of buildings in the green transition. We face a huge challenge. The global use of energy and CO2 emissions from the built environment is one of the biggest problems we have to address in order for us to meet the climate target set. But the question is, what contribution can buildings make in the green transition towards using more renewable energy? Are buildings just an unintelligent energy consumer, or can they do more than just using less energy? Can buildings contribute in a broader sense towards meeting our climate target? And if so, how? So this is what I like to discuss. But first, just a very quick introduction to Priva. Priva Building Automation, we are a developer and supplier of building automation. We are the market leaders in the Netherlands with about 40% of the Dutch market. The company was founded in the 1950s, and today we have 450 employees with 95 million euro turnover. Out of this, we invest 20% in research and development. We are represented internationally through a partner network, and we are very proud to be partner of Vitane Building Controls here in Denmark for the last 10 years. Vitane in terms of have a subnet of local Danish partners that is representing Vitane and Priva. Recently, just a few weeks ago, we launched Priva Lab for Innovation. This is our home for our intelligent digital solutions for smart buildings, where we are further developing these applications both technically and commercially. And there's a dedicated website, privalabforinnovation.com, you may like to refer to. Priva's ambitions was clearly stated in 2012, and we made it clear that we want to contribute to a sustainable future in which a growing world population can live healthy and a comfortable life. And we are convinced that our technology and knowledge of energy optimization, energy transition, and building automation can help cities transform into sustainable urban deltas. So the green transition then. More and more renewable energy will be used. We're going to rely on wind power, solar PV energy, which is all fluctuating energy resources. At the same time as we're switching off our gas and oil powered plants. With more fluctuating energy resources, we will be facing timing issues, the mismatch between when it's produced and when we need to use it. So during peak times, it will not necessarily be when most of the energy is produced. And therefore, we need to learn to balance the energy supply and demands. Just some key figures, but you probably are very familiar with these, but I just want to make a couple of points. With more and more reliant on flexible energy resources from wind and sun, we are going to double the production in Denmark, expected to do so between 2018 and 2030. At the same time, as we're relying more and more on renewable sources, the electrification of society is increasing. Even district heating will by 2030 consist of 12% of electric boilers and heat pumps. And of course, we're seeing that the cars on the roads becoming more and more electric. And by 2030 in Denmark, we expect 36% of sales with 11% of the stock to be made up of electric or plug-in cars. And this is, of course, just the beginning. So the electrification will increase rapidly from this point onwards. So how can we solve this dilemma between production and usage? How can we store this renewable energy in an effective manner? There's a lot of discussions about batteries on a micro level in buildings and building complexes to fit batteries to store energy and take off the peak loads. We can maybe also use cars to use them to discharge in the morning to offload during the peaks. But of course, cars then need to be charged when they're ready to drive away. But the building itself, maybe it's not discussed that much what it can do in order to store energy. Can we actually store energy in the building itself as heat or as cold? And how can we manage that? Can buildings become smart and capable of communicating exactly how much energy will be required for the next 24 hours? This is where the potential of AI solution will be possible to make a great contribution. With an AI solution, it will be possible to plan and forecast and predict how much energy will be required. And with these predictions, it will then be possible to balance the energy consumption with the storage of energy and optimizing the flows between all of the different connected components. There's so many different influences and decisions that you need to make. So an AI solution is really going to be the tool to achieve this by. At Priva Lab for Innovation, we have developed such AI solutions. And currently, we are using eco-building on many sites in Denmark, in Sweden, in the Netherlands, Belgium, UK, and Germany. In Denmark, we have a number of installations with Vitani and also including those projects within the PKI initiative. That is a sponsored initiative by Elforsk, by Vitani, and also by Priva. In addition to that, we are developing eco-grids. And I'm going to come into the detail of this a little bit more in a minute. But we are now conducting trials in the Netherlands and Belgium, and we are ready now to seek initial trials in Denmark. And we really look forward to working with different building owners and other stakeholders regarding this. Buildings in general, they are becoming more and more complex. And in the past, it was sufficient to have one strategic system, one building automation system to control the comfort levels by controlling the heating, ventilation, and air conditioning system. But as we're adding in more components, we're adding in solar PV panels, we're adding in cars, we connect to energy contracts, maybe with flexible pricing. We are able to take the weather forecast into consideration. Solar panels, electric cars can provide then more capacity for the building. If we're then also adding in locally installed batteries and maybe are using cars to deliver energy to the building, at the same time we need to charge those cars, this is when it's becoming more and more complex, and we really will benefit from an AI solution to manage all of these different components. So a strategic system that have the capability to take all of these different influences into consideration and optimize how much energy used by which component at what times. A few words about eco-building. Eco-building is an intelligent cloud-based layer of software that is sitting on top of the existing building management system. It is not a control system in the cloud that replaces the building management system, but it's something that adds to it and become that layer on top. So therefore, it can be applied to any buildings that has a modern BMS. Doesn't need to be Priva, can be of any modern BMS make. Eco-building is then using a digital twin, using AI technology and data. And with this, it's possible to predict how much energy will be used for the different components. And a digital twin, that is really a digital representation of the building, its properties, and the HVAC system. And with these predictions that it will be made possible to do, we then take into consideration the weather forecast, the thermal inertia of the building itself, its occupancy levels, and if relevant, flexible pricing. And by optimizing with this solution, it's then possible to save cost, save energy, and of course, reduce the energy usage and the CO2 emissions. EcoGrid is then an extension of that, like a sister application that is a further development, where we're also building in more of the energy-related components in a microgrid. Still based on a digital twin and AI technology, and we are now optimizing and directing the energy flows, including taking into the equation solar PV, batteries, cars, etc. So looking at the energy tariffs, the energy demands and the supplies, the availability of storage, the weather forecast will be important aspects of it. The result will be a balanced system that is minimizing the energy cost and decrease the required contract capacity because the peak loads will be less. So eco-building and eco-grid together uses AI technology, live data, and a digital twin. The digital twin of the buildings, its installation, including the connected energy components. It's based on live data, AI, and a digital twin. When we combine these two AI solutions, that's when the real becomes really interesting. It will make it possible to turn the building into a smart consumer. A smart consumer that knows when energy is available and use it when it is available, not during peak times. Possible to strategically plan and optimize when and how the energy is used. For example, we can heat the building or cool the building early in the morning hours before peak times, and then turn the energy supplies off when most other users in society are using a lot of electricity. We will be able to use wind and solar electricity flexibly, store it in batteries or cars when we can, or use it to run the heat pump for the heating and cooling. If it is available and we can't use it in another better way, we can also sell it back to the grid. So the AI solutions really combine and considers then the timing, the availability, and the pricing. So AI solutions such as EcoGrid and EcoBuilding then can be very powerful with all a big set of large input parameters to accurately predict 24 hours ahead, making the right decision, and as a result, make the most of the energy available. With this strategic approach, I believe will be essential to succeed with balancing supply and demand of energy when it is produced by more and more fluctuating energy resources. The building itself on a micro level will be able to decrease contract capacity by evening out when energy is used. on a macro level, when more and more buildings are connected to this technology, they will together make a significant contribution in evening out between supply and demand, so that we can better make use of the flexible fluctuating energy resources that we will be depending on. From a building owner point of view, why should I invest in these type of technologies? Well, there's a few compelling reasons, I feel. First of all, it will be possible to save cost in the electricity contract by decreasing the maximum contract capacity. Furthermore, it will be possible to save money by using the flexible electricity pricing, which surely will become more and more prevalent, with less cost during off-peak hours and a higher price during peak hours. So that will make a financial contribution. And of course, it will also contribute to a greener future, saving costs at the same time. I'd like to finish the presentation with looking at two examples, one with eco-building and one with Skole in Silkeborg kommun. And another example with EcoGrid, when we are used this as an input for a design of a new building in the Netherlands. But let's start first at Skole with an eco-building application currently running. Skole has a number of different buildings, all of which represent a zone in the system. There are a few air handling units as well, and one of the buildings consists of 3 zones, and that's the gym. It has a district heating connection, and I'm going to quickly switch to the actual application of eco-building. And I'd like to just give you an example here on how energy is used based on the prediction of the weather, for example, into the future. So on this graph here, we have at the top, we have the comfort requirements, with the red line being the maximum temperature allowed and the yellow line, the minimum temperature. It's quite a big difference during a weekend and during weeknights. While during the daytime, it is a more narrow gap between the maximum and the minimum allowed. By the way, I have chosen a week, about 2.5 weeks ago, where there was relatively cold winter conditions. We needed to use heating, but at the same time, the sun had an influence on the heating requirements. The other graphs here is the sun, and that's the pink reddish line that we see the peaks here during the day. The blue, dark blue is the outside temperature, and then we have the heat supply by the heating system. So during the weekend, we saw that we're starting to approach the minimum allowed temperature conditions. So we had the heating on. Then we also realized that was going to be a sun is going to shine this day. And even though in the winter conditions, it would make a contribution. And therefore, the heating was turned off even before the sun actually started to make a major contribution. Then it was off all during the day and only came in after the sun had stopped giving its influence and the temperature dropped in the zone. An example during a normal occupied day is that the heating also here came off during the day because of the sun influence, while in other of the weekdays, it was less sun predicted, and therefore we needed to have the heating on during some parts of the day. All the time to maintain the comfort conditions, sitting pretty close to the minimum allowed level. So that's an example of eco-building running today at Skole in Silkeborg kommun. The last example I then like to give is about EcoGrid. This is the project that is being designed for Hege in the Netherlands. They are building a new building in Den Bosch. And here we have used eco-building with EcoGrid to do a study of the feasibility of decreasing the contract capacity of the electricity contract. And the considered capacity initially was 70 kilowatt to 140 kilowatt. And we then did a few scenarios. We looked at the scenario without the battery, with a 92 kilowatt hour battery, and with a 184 kilowatt hour battery. We studied 2 different days, one cold day in January and a hot day in August. So one with cold and not much sun, one with warm conditions with a lot of sun. Making the design and the calculations, we had to add in the different properties of the building and its HVAC installation and the different energy components. So putting those properties into the model. We furthermore added the comfort definitions for minimum and maximum temperature in the zone during occupied and non-occupied time. And of course, feeding in the temperature conditions and the sun and the wind conditions over those 2 days. And with EcoBuilding, EcoGrid, we were also from a design point of view able to optimize and simulate the energy requirements. We studied energy flows, how effectively we could meet the comfort requirements, at the same time as we consider thermal losses and electrical losses in the different conversions of energy in the system. So the AI solutions ensured that we always were able to use the energy in the most optimal way. So the building itself, designed with solar PV panels, it is requiring inverters to convert between AC and DC power, had heat pumps for heating and cooling, air handling units with thermal wheels, and in total, there was 8 zones that were controlled individually. So if we look just on the left-hand side here, we see the weather, shining sun on the PV panels. That in turn feed to one inverter that goes directly onto the grid and onto the heat pump, with another inverter that converts to DC power to the battery, to charge the battery. Then there is another inverter that is connected to the grid if we want to convert from AC to DC to charge the battery. And of course, when the electricity in the battery is going to be used by the building, connect to the grid, then onto the building components by another inverter. The efficiency of these different inverters was also considered in the model, so we could make the best use of all available energy. The conclusion then was that of the starting point, thinking about 140 kilowatt as the maximum contract capacity, we now realize by just applying EcoBuilding, but without using a battery, we could decrease the contract capacity from 140 kilowatt down to 100 kilowatt. If we did add in a battery, say of 92 kilowatt hours, then we could drop the capacity from the 100 kilowatt down to 90 kilowatt. And with a bigger battery, 184 kilowatt hours, then we could drop the capacity of the contract down to 80 kilowatt. But below 80 kilowatt, the model showed that we could not rely on meeting the comfort requirements in the buildings if there was less than 80 kilowatt. So that's, I think, is an interesting example to using EcoGrid also for design conditions. So in conclusion, with increasing reliance on fluctuating energy, at the same time as we experience a broad electrification of society, I believe we got a big challenge ahead. And therefore, I think it's essential and paramount that we can make the most of buildings' potentials to store and use energy flexibly. Any questions or any comments? Thank you very much.
Thank you too, Anders. And there are some questions in the on the screen, and I will read them loud. What are the requirements to the part of the trial? You mentioned that you wanted some trial.
Yes. We are looking for starting to doing trials where we have buildings that are using different types of energy resources, maybe solar PV, maybe have maybe connection into cars as well. So as I said, we are doing some early trials in Belgium and Netherlands with regards to eco-grid. And we are now looking to buildings that have some of these energy different components, and we can start doing that. But we would do that at the same time as applying eco-building. And eco-building is, of course, has sort of passed the trial stage. And we are applying it to buildings in Denmark today. So the eco-grid components would be an addition to that, where we then are seeking buildings that could benefit from connecting solar PV, connecting cars, and flexibly using energy supplied from the grid, and maybe even supplying it back to the grid as well.
And in addition, how many sensors are needed and to what cost for the installation in total?
During all of the projects we have done in Denmark, I don't think we have added in any or many sensors at all, because the sensors exists in the building automation system normally. One requirement is that we can have a representative temperature of the different zones, because you divide this building into different zones, a bigger portion of the building that have common characters. It's not an individual room or a conference room, it's a bigger portion of the building. So say a 7,000 square meter building might be split up into 4, 5, 6, 7 zones. And it's important that we have represented space temperature conditions of these zones. And if we don't have that, then we need to add such sensors. But they are normally part of the existing BMS.
Mm-hmm. So it's in a small scale.
Yeah, and it's about interfacing the solution with the local install system to read data and steer set points in the system. So that is the application that you need to integrate it with the existing solution.
Mm-hmm. And I'll combine two questions. How do you get the price signals, the cost? And can you adjust the energy consumption according to CO2 level rather than price?
Yeah, there is, of course, it little bit depends on what you're putting as your priority in terms of the optimization. Because you sometimes can use less CO2 if you pay a little bit more. So that is a sort of a client decision, whether the first priority is to really minimize the use of energy, or if the priority is really CO2. And we have seen on some examples. There is one site in the Netherlands where the use of eco-building resulted in that the consumption and the use of the boilers decreased significantly. Less than 50% of the energy compared to previous year went into the boiler plant, while the electricity used through the heat pumps maintained pretty much the same or even increased a little bit. But overall, the CO2 savings were very big savings on that.
Mm-hmm. And another question, can you use the predictive systems to design changes in the building in connection when you renovate?
You can apply it and look at the influences of the different energy flows before you build the building. And of course, when you have an existing building, you can look at the current situation. And if you're then introducing certain changes of that design, then you can use the model to then predict how much more energy or how much less energy we need from the different parts of the system. So yes, you can definitely add that as part of it on an existing building.
And that was the end of the session. Thank you very much,
Thank you very much.
It was very interesting. Good luck with the future. Yes.
Yeah, very much look forward to it and work together with you and Vitana as our partner in Denmark. So thank you.
Thank you. Og med det runder vi af. Så tak for endnu en god session, og pas på jer selv derude.